we're talking about 3 divisors.
Okay, 3 divisors. Thank you. 3 divisors. Okay, so with number 2, how many divisors? For,
2.
2.
1 and 2.
1 and 2. So we only have 2 divisors. 4. Okay? 4, how many divisors?
3.
Which are those?
1, 2, 4.
So if I give you a number bigger than 2, can you tell me how many 2 divisors you can be sure there? How many?
1 and itself.
Well done, yeah. So any number, yeah. Let's say it's 9. 9. How many divisors?
1, 3, 9.
1, 3, 9. See, it always has 1 and an Excel, yeah. Okay, so if it's 9, you also need to tell me it's 2, right? Okay.
Yeah.
But how about 6?
4. 1, 2, 3, 4. No, 1, 2, 3, 6.
Yeah, so that's 4 divisors, so which is not. Okay, so if the input is 4, 9, you tell me yes, 2. Otherwise it's false. Easy, yeah, easy peasy. How can we do it?
We could.
How can we do it? Okay, any thoughts? Any thoughts? How are we checking it?
How can we check it, Chesley? What do you think?
How can we check it? Remember, this is kind of, we talk about, yeah, brute forcing, how could, quite the same, similar approach when we check about a number if it's a prime number, remember? Yeah?
Yeah.
We always check do we need to check the prime factor, the factors up to n? Do we need to check?
What's n?
Look, if this number is n, do we need to check the factors up to n? The divisors up to n?
No.
No, why is that? Yeah,
Because you only need to go halfway through.
only halfway through? We can do better than half, right? Yeah. For example, 6, we don't need to go over 6, yeah?
Mm.
Yeah. But can we do better?
You can only go up to 3. Or just 3, halfway.
Yeah, halfway. I know. Let's put it this way: 100. We want to find out the divisors, yeah, the factors, divisors of 100. What are those?
A lot.
Okay,
6, 7.
let's try it.
7.
1, 2, 4.
4, 5, 25, no, 20,
10.
20, 25,
Yeah? Sorry?
50,
Okay.
20.
After this point, I don't think we need to continue. Why is that? Because look, I have 1. I know the other one is 100. I know 2. The other one is 50. 4.
24.
25. 5.
20.
You see?
10.
Okay, so you can find any number. 10, 10, 20. You see? So what's that? Every time you find the divisor, n divided by the divisor is the divisor, right? Got it? Let's say I already found the 4. What does it mean? 4 is one of the divisors. So what does it mean? For 100, 25 is also one of the divisors. Yeah?
Yeah.
Okay, so is it half? No. For this one is what? Square root 100. Yeah, got it? Yeah, 100. Yeah, 10. That's where they come from. So it's up to square root. Yeah. For example, here as well, right? But this one, why is it 3? Because your square root of 6 is 2 point something, and it's up to 3. Okay, so it's close to half. That's a very special case here. Got it? 9, square root of 9 is 3. So we only check up to 3. We don't need to check above. Got it? Because look, I have 3. The other half is what? Also 3. Got it? And this is a special case when the number times itself is n. These two divisors collapse, yeah? The same collapse. So we just need to check the divisor, yeah? And that's it. Easy peasy. Define, let's say, 3 divisors, okay, divisor. N, okay? Let's say, if n equal 1, if it's a positive, yeah? If it equals 1, return false, right? Yeah? If n equals 1 or n equals 2, right? Okay? Then we have a divisor. We have a counter c equals 3. And we have I also start from 2, okay? C equals 2, okay? Because the 2, c from 1 and itself, okay? C equals 1, 2 because we counted 1 and itself, and then we start with 2. Okay? Then look, while I times I smaller than what? If this divisor we are trying to check. If I times I smaller than what?
Smaller than n.
Yeah, n, right? And then we have to check. If n can be divided by I, right? If n can be divided by I, what does it mean? If I is one of the divisor, right?
Mm-hmm.
So I have to c plus equal 1, right? But also here, if I times I not equals, if I times I not equals
You need to I.
n, what does it mean? If I times I not equals n means that because we look, we have n divided by, we have I divisor. So the other half is what? N divided by I, right? Yeah? And then I and I, when these two are equal, when I is equals n divided I, like 3, right? Look, if n equals 9, when I is 3. So we need to add 1, right? But 3 times 3,
So you need to I plus equals 1, I think.
here again, c plus equals 1, right? Does it make sense? Do you understand what this bit is?
Do you
Look,
guess?
because wait, look.
Do you?
Because look, let's take about this 100, yeah? If we found out the 20, if I found out the 5 plus 1, yeah? And this is means that I found another 1, because I found, every time I found 2, right? Except if I found a 10, I found the other one is 10. I only can calculate 1 because these two are the same, right? Got it? Got it? Yeah?
Yeah.
Make sense?
Yeah.
Does it make sense?
Yeah.
Yeah, okay. I'm going to ask you this later, okay? Think about it. Okay, and then now, after this, we just need to return what? C, what?
Equals 3.
Yeah, this is the number of big 2. What are these 2 means? What does these 2 mean?
That's
What's these 2 mean? Why is set to 2 at
what
the
does
beginning?
it mean, Chesley? Because you do the beginning and the end.
Yeah, the beginning and end. So let's 1 and n, okay? 2, 1 and n factors. And why here has a plus 1 here?
Because we
What?
No.
Why this there's a 1 here and why this has 1 here?
Because we have like you found a 5 and then you
Yeah, because
you
it
divided it by the n and then you find 20, so 20 is also divisor.
okay. And if it's the same, if I times I equals n, then you don't add it. Yeah, you don't add the same number twice, right? Some divisor twice. Yeah. For example, if n is 25,
Fine.
n is 25, and then I is 5.
Divide.
Right? You find the 5. But 5 times 5. Yeah.
Divisors.
So you only add 1 here, right? Alright? Because 5. Alright, Eric? But if n is 100, it means that 5 and 20. Okay, okay. What's the time complexity for this function, for this one? Huh? What's the time complexity? And here, what's time complexity? Come on, that's very easy.
O-N-M.
Okay, here is the missing I plus equal 1. Right? Yeah?
Yeah.
What's the what's the time complexity? If I want to pick a number, start from 1, or 2,
O1.
and then up to which?
N.
N? Look, this is I times I.
I.
So a number squares itself until it hits N. So what's this?
I squared.
Yeah, I squared. This, not this, yeah. O-N SQRT. Right, because look, N is 100 and I is 10, right? Am I right? Yeah? Can you not do it, please? Okay. Look, here, if we can put an if here. We can put an if here. If C is already bigger than 3, is there a way we can just return false immediately, right? We don't need to continue, right? If at this point, if we increment C is more than 3 here, alright? So what should we do here? We add an if.
Is C bigger than 3? Return false.
We're done. That's a speed up, yeah? That's an optimization. Yeah? Okay, what's optimization? To make it a bit better, to improve it.
To make it longer.
Because look, if this is going to take a few other iterations to end, and we already found more than 3 divisors, right? So the answer is already known as false, right? So we can skip the rest of the checks and return immediately false. That's what it
Why
means.
don't you do have a beginning?
Because at the beginning you don't know, you're not sure. I put it here because look, every time I increment it here, I increment a C. And once I found it's bigger than 3, the answer is false, right? There's no need to continue until we exhausted the I. Am I right? Alright? Got it?
Yeah.
Okay. Okay, so that would be we actually don't need these if as well. We can just do this.
Oh, what?
Yeah, we can just start with C equals I equals C equals 2, and 1 I times I smaller equal than N equivalent than do this. Okay. Okay. Okay, I'm going to.
What?
Okay, come on. Should be easy, lah.
No, it isn't.
Ryan, you want to help the girl? Ryan, you. Come on, that's it. Ryan. Ryan. Yeah, your turn.
Okay.
Huh?
Seriously, your turn.
Yeah? Okay, we're done.
C plus equals what?
Yeah? And then we also need to make sure C plus equal. What? C plus equal 1, we're done. And what? We found the ones, we found the I, and we also found N divided by in what cases. We need to check if I and N equal I is the same, right? So if I, yes, I what? I times I, if it's not equals. Okay, if I times I.
Chesley.
Okay. If I times I not equals what? Not equals n. And then what? Come on. And then what? C plus equal 1, right? Yeah, that's it. And then you put it here. Yeah, that's right. Yeah. And then also you can put an if here. Yeah. If C, if C bigger than 3, then yeah, and then return false, right? Okay, well done. You got it. Okay. What's the time complexity? What's the time complexity? No.
O(n) square.
That's not O(n) square. What's the time complexity?
Then what is it? O(n) squared.
Square. O.
O(n) SQRT.
SQRT. Okay.
Yeah, that's what we meant.
Or you can write it O(n) 0.5. Okay. Everybody. Square root is actually this one, yeah? 0.5. Got it?
O(n) 0.5.
Okay. What's the space complexity? Oh what?
O(1).
O(1). Well done. Okay, that's it for today. Good job.
Bye-bye. Bye-bye. Bye-bye.
Bye-bye. Okay, that's it. Bye-bye.